Lift on an aeroplane wing. Lift on an aeroplane wing. In the diagram, the aeroplane wing is shown. This is the aeroplane wing. There are three parts of aeroplane wing: slats, flap, and aileron. This is the slat of aeroplane wing, and that part is flap, and also that part is flap, and also we can denote aileron. This is the aileron of aeroplane wing. Aileron of aeroplane wing. There are three parts of aeroplane wing, and these three parts form a typical shape. That means different parts of aeroplane wing. Different parts of aeroplane wing, that is slat, flap, and aileron, form a very special shape. In fluid mechanics. Different parts of aeroplane wing form a very special shape in fluid mechanics, which is known as the airfoil shape. It should be shape, S-H-A-P-E, airfoil shape. This typical or very special shape of the aeroplane wing is known as airfoil shape. We can denote the airfoil shape of aeroplane wing. This is the airfoil shape of aeroplane wing. In the diagram, we are denoting the airfoil shape. This is also the airfoil shape in the back portion of aeroplane wing. And leading edge of the airfoil is more thick than the trailing edge of the airfoil. And this is the upper surface with more curvature with respect to the lower surface, and we can write down the same, that is upper surface of the aeroplane wing. The upper surface of the aeroplane wing of airfoil shape is more curved than its lower surface. The upper surface of the aeroplane wing with airfoil shape is more curved than its lower surface, and its leading edge is more thick than its trailing edge. Its leading edge is more thick than its trailing edge. And we can denote the airfoil shape on the aeroplane wing. This is the airfoil shape of the wing, in which its leading edge is more thick than its trailing edge. And the airfoil shape means what? It will be viewed if it is cut across its cross section, and in which its leading edge is more thick than its trailing edge. This is the sketch diagram of aeroplane wing, and we can denote the airfoil shape of aeroplane wing. The upper surface is more curved with respect to the lower surface. The upper surface is more curved with respect to the lower surface, and lower surface is less curved. Turbofan engine is attached to the lower portion of aeroplane wing, and this turbofan engine emits exhaust gases in backward direction. And there will be a thrust on the turbofan engine or reaction force on the turbofan engine, which is acting in forward direction, and due to this reaction force, aeroplane moves in forward direction. When the turbofan engine attached to the lower surface of the aeroplane wing, emits exhaust gases with high velocity jet. When the turbofan engine attached to the lower surface of aeroplane wing emits exhaust gas with high velocity, the reaction force provided by the high velocity jet gives the turbofan engine sufficient thrust to move in forward direction. This reaction force of high velocity jet gives the turbofan engine thrust and makes the aeroplane to move in forward direction. Makes the aeroplane to move in forward direction. As the aeroplane move in forward direction, as the aeroplane move in forward direction, the air flow, the air flows in the form of streamlines. As the aeroplane move in forward direction, the air flows in the form of streamlines over the wings of aeroplane. The air flows in the form of streamlines over the wings of aeroplane. So in the diagram, aeroplane moves in forward direction horizontally. So this is that means aeroplane moves in forward direction horizontally, and streamlines of air or air flows in the form of streamlines, which is shown in the figure. So here air flows in the form of streamlines on the upper surface of aeroplane in this way or with the greater speed. This is what the streamline of air flow. This is the flow of air, and this air flows in the form of streamline. Similarly, there will be streamlines of air which will be flowing, touching the lower surface of aeroplane wing. We can draw the airfoil shape of aeroplane wing. This is the airfoil shape. Its leading edge is more thick than its trailing edge. This is the wing of aeroplane with airfoil shape or aerofoil shape. Wing with airfoil shape. Its leading edge is more thick than its trailing edge, and this aeroplane wing is moving in forward direction. Aeroplane wing is moving in forward direction horizontally initially, and air will be flowing in the backward direction. So this is the streamline of air which is flowing tangentially and touching the upper surface of the airfoil. This is the streamline of air touching the upper surface of the wing. This is the streamline of air flow touching the upper surface of aeroplane wing. Similarly, we can denote the streamline of air touching the lower surface of the wing. Air is flowing in the form of streamline and touching the lower surface of the aeroplane wing. So this is the streamline of air which is flowing in the backward direction and touching the lower surface of the aeroplane wing. Velocity, tangential velocity of airflow on the streamline touching the upper surface is v1, and similarly v2 is the velocity of airflow on the streamline touching the lower surface of the wing. And here v1 is greater than v2, that means velocity of airflow touching the upper surface of aeroplane wing is greater than that of the lower surface. As the velocity of airflow is smaller, that's why a greater pressure will be acting on the lower surface, which and also it acts upwards. Greater pressure P2 will be acting on the lower surface because air flows with lesser speed uh, touching the lower surface of the aeroplane wing, and downward lower pressure will be acting on the upper surface of the aeroplane wing. This is the P1 is the lower pressure which acts downwards on the upper surface of the aeroplane wing. As a result, a pressure difference P1 minus P2 will be acting upwards, and upwards or lift will act, and this lift or force is equal to the pressure difference into area of cross section of the aeroplane wing. And here, as V1 is greater than V2, that's why P2 will be greater than P1. This force is actually lift on the aeroplane wing, and this force acts vertically upwards due to pressure difference between the upper surface and lower surface of the aeroplane wing. As the upper surface of the aeroplane wing with airfoil shape, as the upper surface of aeroplane wing with the airfoil shape is more curved than its lower surface, as the upper surface of aeroplane wing with the airfoil shape is more curved than its lower surface, comma, the speed of airflow the speed of airflow the speed of airflow touching tangentially the upper surface of the aeroplane wing will be greater than that of will be greater and the speed of air flow touching tangentially the upper surface is v1 is greater than the speed of airflow, that is v2, below the wings. According to Bernoulli's theorem, comma, and Bernoulli's theorem means sum of pressure energy, kinetic energy, and potential energy per unit volume of air is constant. That is P plus half rho V square plus rho GH equal constant, where rho is the density of air. The upward pressure under bracket P2 the upward pressure under bracket P2 acting on the lower surface of the aeroplane wing, acting on the lower surface with less curvature or with less curvature is greater than the downward pressure P1 acting on the upper surface of the aeroplane wing is greater than the downward pressure P1 acting on the upper surface, which is more curved, full stop. As V1 is greater than V2, P1 less than P2, that means that is P2 greater than P1, that is upward pressure is greater than the downward pressure. We can denote the airfoil shape of aeroplane wing. Air is flowing in the backward direction in the form of streamlines. These are the blue colored lines at the streamlines of airflow touching the upper surface and lower surface of the aeroplane wing. Lower pressure P1 is acting downwards on the upper surface of aeroplane wing, and upward pressure P2 is acting on the lower surface of aeroplane wing, and due to pressure difference P2 minus P1 will be acting in upward direction. Due to this pressure difference P2 minus P1 acting on the aeroplane wing with airfoil shape, due to the pressure difference P2 minus P1 on the sides of the wing, a vertical lift under bracket F is the force of lift, F equal P2 minus P1, which is the pressure difference into 2A, where A is the area of cross section of each wing and 2A is the total area of the two wings. acts on the aeroplane due to pressure difference on the sides of the wings. Mg is the weight of the aeroplane, and we can denote the lift or vertically upward force F equal P2 minus P1 into 2a, where a is the area of cross section of each wing and 2a is the total area of cross section of the two wings of the aeroplane. So here a equal area of cross section of each wing of the aeroplane wing. If F is greater than mg, that means the lift or upward force is greater than the force of gravity, then the aeroplane wing, then the aeroplane will be lifted up, will be lifted up. When this lift, that is, when this lift, that is the upward force, when this lift, that is upward force, F equal P2 minus P1 into 2a, is greater than, is greater than or is sufficient, this lift or upward force is sufficient to overcome the gravity. This lift is sufficient to overcome the gravity, that is the weight of the aeroplane, that is mg, sufficient to overcome the gravitational pull on the aeroplane. The aeroplane will take off. The aeroplane will take off. That is, it will be lifted. It will be lifted up. It will be lifted up. So in this case, the aeroplane will move diagonally in air. That is, aeroplane will be lifted in air diagonally as shown in the figure.